Hi, it's Mr. Anderson, and today I'm going to show you how to name chemical compounds. And the reason we do that is when you're done, you should be able to pick up anything and figure out what's actually in it. And so if we've got a can of Mountain Dew, this is old school Mountain Dew, and we look at what's inside it, there's going to be water and sugar, and we know what those things are, but there's also going to be, for example, sodium benzoate. And at the end, you'll actually know what that is. Or calcium disodium. You should be able to figure that out when we're done, what that actually is. And so let's get started. First of all, let's start with the rule of thumb. The rule of thumb says that if you hold your thumb up to the periodic table, things on one side of your thumb are going to be nonmetals. And so if I hold it up like this, everything on this side of my thumb is going to be a nonmetal. Everything on this side of my thumb is going to be a metal. And so there are really just three types of bonds. If you have two metals together, we call that metallic bond. If you have two nonmetals together, we call that a covalent bond. And then if you have one metal and one nonmetal together, we call that an ionic bond. And if you don't know how to figure out what kind of a bond it is, you want to look back to the previous podcast where I talked about what exactly that is. One quick way to do it is to just look at the differences in the electronegativities. So calcium is 1. If we look over here at, for example, nitrogen, that's 3.04. So I should be able to tell right away that that's going to be an ionic bond just from the electronegativities. Okay. Let's start with the easiest one, and that is naming covalent compounds. First of all, you have to figure out, how do I know which of the two atoms comes first? In other words, why is it carbon dioxide and not dioxygen carbide, excuse me. And so let's look on the periodic table, and I'll talk about Rule 1 and Rule 2. Rule 1 says you always start with the lower group number. And so why is it H2O? It's because hydrogen has a lower group number than oxygen, which is over here. And so hydrogen gets to go first. Now you might immediately, if you're smart, be thinking, well, okay, that works. We're always going to go kind of from left to right. But what if they're in the same column? And so sulfur dioxide is an example of that. We've got sulfur here, and we've got oxygen right above it. So who goes first? Well, you're always going to start with the one that has a greater period number. And remember, period numbers are going to increase as we go down the periodic table. And so sulfur goes before oxygen just because it's lower on the periodic table. So once we figured out who goes first, then it's really easy to figure out the names of these. So let's start with carbon dioxide. Carbon dioxide carbon's going to go first. Whenever you're naming covalent compounds, you're just going to put the name of the atom first, and then you're going to put the anion second. These little subscripts tell you how many of those ions you actually have. One more thing. So first of all, we put the atom first, and then we put the second as an ion, or in this case, it's a negative ion called an anion. And then we're just going to use this chart over here to figure out how many of them we have. It goes from mono, meaning 1, all the way up to deca, meaning 10. We rarely use these ones down here, but you might as well learn these first 4 because we use those quite a bit. So let's start with carbon dioxide. Now you might want to say, well, there's only one carbon, and so let's call that monocarbon. But you can see here that you don't put a mono on the first one. Also, if we have like monooxide, that sounds kind of silly. You just kind of lump that together and that'd be monoxide. So let's start with the first one. So we've got carbon first, so we're just going to write the name of that element. So carbon's first. And then we have 2 of the oxygens, and so that's going to be dioxide. And you've heard that before, carbon dioxide. Let's look at the next one then. What's the first element? Element's going to be, P is going to be phosphorus. And then we have N next. Now it's not nitrogen, it's going to be the ion of nitrogen. So let's kind of skip forward and see what that is. It's way up here. Let me get it in a color you can see. It's going to be nitride. And so if you're ever trying to figure out what the ions are, you can look on we use this in class, periodic table of ions, and it's going to tell you what the name of that is. So let's go back and finish this one out. So this one, we have phosphorus, but we have 3 of those. And so this one's going to be tri-phosphorus. And then we've got 4 of these nitrides, and so that's going to be tetranitride. So that's the name of P3N4. If we go to the next one, this is carbon. So we're going to just write the name first, carbon. And then we've got 4 of these hydrides. And so that's going to be carbon tetrahydride. So it looks, if you look at this again, we're always writing the atom number or the atom name first, and then we're always going to write this, instead of tetrahydrogen, it's going to be hydride. We're going to write that anion for that. So that's naming covalent compounds. Let me erase that, and let's go to ionic compounds. Ionic compounds, it's actually easier. There's just two rules. Rule number one, you're always going to write the cation first and the anion second. So you're always going to write the positive charge first and the negative charge second. And the only other tweak on that is that there are some elements, let's kind of skip back for a second. So if you look way over here, let's look at, for example, iron. Iron, you can write iron in a number of different ways. We can have iron 3, we can have iron 2. Some of these will have multiple states that they can have. And so if there ever could be more than one type, like iron 3 or iron 2, in Roman numerals we're going to know which one of those are, which one they are. And so let's take a look at one of these and actually do that. So let's look at the first one. So this is lithium and oxygen. And so all we do is look on our chart and we figure out what the name of those ions are. So if we go back here, here's lithium all the way over here. So lithium is going to be the name of the cation. And then we go over here and we find the anion, and it's just simply lithium oxide. And so this one would be lithium oxide. Now if you look at it, why is it written as Li2O? Because lithium has a positive charge, and oxygen, or the oxide anion, is going to have a 2- charge. So we have to have 2 of the positive charges to balance that out. Now let's look at the next one. This one looks a little bit scary. This one, you shouldn't be scared though. If we ever see something that is written in parentheses, that means it's a polyatomic ion. That means it's an ion, it still has a charge, but it's made up of more than one atom. In this case, we have NH4. So let's just go back to our chart and find out where that is. I'm going to look around here until I find it, so it's way over here. So this would be NH4, and that stands for ammonia. And so that's going to be ammonia. And now let's look back at what we had. And now we have a P, and so that's the other part. That's going to be our anion. So let's find that. That's going to be phosphide over here. So if we look at ammonia, there's only one type it can be, NH4, and phosphide is going to be P. And so let's just kind of go forward and write that is. So that is ammonium phosphide. So again, pretty easy. We're just writing the cation first and then the anion second. Now let's look at this one. We've got copper, and then it looks like we have another one of those polyatomic ions. In this case, it's going to be an anion. So let's go find it on the chart. First of all, we have to find copper. And so copper, I've kind of written all over it, but copper is going to be, where's copper going to be? Copper is going to be right here. And so copper can have 2 states. Copper can either be Cu2+, or it could also be Cu1+, or just plus. And so we have to figure out which one it's going to be. So let's go take a look at that. So here we've got copper, and now we've got this. We've got to figure out what that NO3 is. So let's go back again. So where is NO3? NO3 is going to be written on our chart. Looks like I'm going to have to erase some of this stuff. So if we look up here, NO3 on our chart is going to be NO3 is going to be nitrate, and so nitrate is going to be right here. It's NO3 and it has a 1- charge. And so now we've got our copper, which we know could be copper 2 or copper 1, and now we know that nitrate has a -1 charge. So let's try and figure out what this is. So nitrate has a -1 charge, so this is -1 for this nitrate right here. But we don't just have one of them, we actually have 2 of those. That's what the subscript means down here. And so on the right side of this, we have 2 of these -1 charges, and so we have a 2- charge on the right side. If you look on the left side, well, what copper do we have? Well, we know right away that since there's 2- charge on this side, we actually have copper 2. And so let's write that out. It's going to be copper. And now we know it's going to be copper 2, so in Roman numerals in there, I'm going to put copper 2, and that's going to be nitrate. So again, the only time we have to write those Roman numerals is if it could exist in 2 different states. Let's go to the next one. Looks like we've got nickel here, and then we've got SO3. So figure out what SO3 is. Let's go back. So let's find SO3 on here. SO3 is actually going to be sulfite, and it has a 2- charge. Now if we find nickel, nickel can either be nickel 2 or it can be nickel 3. So again, we've got sulfite and we've got nickel, and you got to kind of switch between these. So now we've got nickel and we got sulfite. Sulfite had a, let me go check again, had a 2- charge. And so this has a 2- charge on this side. And we have 3 of those. And so what do we have on the net right side? We actually have a 6- charge on the right side. And so what nickel do we have? Well, if we look on the left side, we have 2 of these. And so to balance out that 6- charge on the right, it has to be nickel 3. And then on the right side, that's going to be sulfite. Let me add some dots here. And so we know that it's balanced on either side, so we're going to call that nickel 3 sulfite.